Okay, so I'd like to introduce you to James Loope from Janrain, who is based just around the corner.
So I'm James Loope. I'm Director of Operations at Janrain. We're based here in Portland, just a couple of blocks from here. If you don't know what we do sort of online user management and third-party user sign-on and a whole suite of applications surrounding that. So if you go to, say, ladygaga.com and sign in with your Facebook account, that's probably us signing you in. Yeah, this is not working now. Great. Well, bear with me. I'll click these things manually, I suppose. So I started at Janrain almost 2 years ago, and we were a really small shop of about 15 people. We had a whole bunch of really smart programmers in that 15 people, and we were using these cool technologies. And out of these cool technologies and these smart people came a really awesome idea. And that's what we have today, is that awesome idea. But when we were 15 people and we had this awesome idea, we thought, well, this awesome idea is going to go to market. We're going to have 1 million people using this awesome idea, and then we're going to have to support those 1 million people somehow. And we were not there yet. This is what we were expecting. More awesomeness, hopefully exponential growth. This is what you always expect when you're a small company, right? This is what we had. That's not a real picture. I just dragged that off the internet, but you can imagine it was scary. We were located in a colo here in Portland. We had a couple of racks, and that's where all of our products were running out of. And we thought, when we get these millions of customers and we experience this exponential growth, we're going to have to do something about this. So we looked at our options. We thought about managed hosting. A lot of people have done managed hosting in the past. I mean, not to really rip on managed service providers, but I've had horrible experiences with them. I don't want this guy managing my systems. And we thought of the other option. Yeah, this is a horrible joke, I know. Which was the cloud. We thought, well, we'll look at the cloud, we'll test it out. We moved some bits to it, and we liked it. And we thought that it had some really great features to it, and that it was totally awesome. So we packed up our wagons, and we moved our stuff to the cloud. But when we got there, we realized we weren't in Kansas anymore. Things are slightly different there. There are some really great features of the cloud. We get on-demand resources, so we didn't have to predict our growth. We didn't have to manage our hardware. We didn't have to monitor our hard drives for RAID failures. We didn't have to, keep spares in stock, which is really unpleasant for a small company. We had all sorts of neat features we didn't have before. We had like a SAN at our disposal, which would have cost us hundreds of thousands of dollars to implement in our own data center. We had the ability to spin up virtual instances and throw them away without building our own massively redundant hardware architecture. And we had these really cool APIs that we could just poke the API and give us a new instance or a new storage unit or a new message bus or any number of the cool things you can do on Amazon. And then we realized there's also negatives to these things. So the fact that we have this sort of impermanence on Amazon, you have a problem, you can throw away an instance, you can make a new one, you can make 100 of them if you need to. But they also just go away sometimes. They're not permanent, so we deal with this impermanence. There's also competition on Amazon, so you're not the only person using it. Netflix is probably using it right next to you. And when they decide to crunch their logs, they're just like dragging down your architecture. So you have to expect timeouts and failures and amazing 503 error cascades. The other downside is the APIs. I don't know if anybody's ever used Amazon's APIs, but some of them are really hard to work with, and some of them don't look like others, and their command line tools are the same way. It looks like they were built by 5 different groups who never talk to each other. We found a solution to that, though. So this is what I was talking about with our instances. So when you're working in sort of the old school data center world, sysadmins, we get really attached to servers. We name them. They're like our little friends. We get sad when we have to get rid of them and upgrade them. That's not the way it works on Amazon. It's not your puppy. It's just an instance. It goes away. It will die. You have to give it up. And we thought there was like this brief respite when Amazon came out with EBS root instances that, oh my God, we can actually have a server be persistent and it won't go away and we can count on that. This isn't really the answer. If you do this, I mean, it will come back when, after it, goes away and comes back and you reboot it, or you can stop it and start it. There are lots of fun uses for it, but you shouldn't count on that because entropy will always get you in the end because that instance will live for 5 years and you're going to change it and somebody else is going to change it and somebody else is going to change it. And if it's not just one, if it's like 50 of them, then you're going to have a giant mess on your hands. So we discovered when we set up our new systems for our new product architectures that the safest and sanest way of doing this is to do it right the first time, to try to build it so that it can be reproduced over and over again. And we started out doing this sort of thing in sort of less abstracted and more specific kind of ways, like bash shell scripts or writing application architectures that try to manage the machines underneath them, which sometimes works and sometimes doesn't. And then we found Puppet. And I thought Puppet was really cool. I looked at Chef, too, at the same time. And the draw to Puppet explicitly for me was the fact that Puppet's DSL sort of forces you to do things correctly. Chef has a huge number of features that are very similar, but Chef lets you write Ruby code right into the manifests. And from a management perspective, I found that a little scary because I felt like, well, why don't I just write the code to do that right in there like it's a shell script? And Puppet makes you actually implement an abstraction. You make a provider for that. Actually do it correctly, you can reuse it. So we started using Puppet, and then a couple of our other engineers started using Puppet as we ramped up to implement things, and we realized Puppet manifests are, they make your configuration management like code. So in order to keep it sane, we had to treat it like code. So we put it in Git, and we managed it that way. So everyone has their own Puppet manifest branch, and you can merge your branches with development and master. And then we discovered that you can use environments too. So we actually match a Git branch to an environment. So we have a development environment and a development master with a bunch of development agents, and you can develop against those without worrying that you're going to blow up the production environment. And then we can cherry pick or merge in changes into master in order to keep the chain of changes correctly. And when our reports come back, they actually have the Git version number in them, so we can see who's responsible for breaking things. And these environments keep us safe. So when you start out doing these things with very small servers that aren't in production, you're changing things on the fly and running it, and you can't do that in production, obviously. So we run development, staging, and production bits and write against the right portion of it. So we're back to the scary APIs that I was talking about previously. I got really tired of using the command line tools that were available for the APIs on Amazon. So I looked for a solution out of it. And there's a couple of libraries that do this. Fog is one of them. Botho for Python is another one. We're a pretty heavy Ruby shop, so we went with Fog just for simplicity's sake. Fog lets you do really awesome things, like write against the APIs as if they were generic, and they're just Ruby objects. So you can spin up an object and apply some methods to it and do fun stuff like this, which this is just a little application that we wrote that launches an Ubuntu AMI and gives it the correct configuration, tells it what it should be and where it should be. And then we pass in a user data string. And we run all Ubuntu, primarily because Ubuntu has really decent support for cloud architectures, particularly on EC2. One of these support features is the cloud init. So this user data script that's passed in, it's just a YAML configuration file, but Ubuntu is smart enough to hook it on boot and know that that PuppetConf agent knows to stick this stuff into the puppet.conf file, and it also installs Puppet and bootstraps it Yeah, so it brings it up, gives it the right cert name, tells it what environment it's in, it syncs its plugins. It sits there waiting for the certificate to be signed. The other neat thing that Cloud Init will do is it will install packages for you, which you'd think, well, you don't need that because you have Puppet to do that, right? But when we use modules that have prerequisites to them, Puppet won't run unless it has the prerequisite to the module in it. So there's a couple of things that we have to install outside of band of Puppet. This is how we solve that. It works really well. So we install things like Git and LVM previous to actually running Puppet so that it works correctly. I'm sure there's a fix for that someday. So after it starts up, the instance comes up and Puppet's waiting for the certificate to be signed. We don't do auto-signing, although I'm sure there's valid ways of making that secure. We just have it come up and wait for the certificate, and then we use the REST API for the master to go and actually sign that certificate. And that works really well. So we have essentially now a tool that we can launch an instance with. We can provision the instance with our common modules, which we use modules to manage our users, our groups that those users are members of, the groups themselves. We distribute SSH pub keys with that. We install our common applications with that, like Git, and our monitoring metric stuff, like we use collectd for metrics, and Nagios, and mcollective itself, which is also important later because, no, never mind. So another step is we set up our DNS with, or via Puppet. So we use Dynect as part of sort of our strategy for keeping our overhead low. We sort of outsource the pieces that we can that are sane to do so. We use Dynect, and we use Amazon's Route 53 DNS services, and they both have REST API access to them. So when an instance comes up, it can actually configure its own DNS when it comes up, which makes it available by the cert name or a sane name as opposed to some big ugly Amazon string. We also use the Puppet LVM module to manage our instance volumes with LVM, which is very convenient. We actually patched it to support striping to LVM2. The new version supports stripe and mirroring, which is kind of neat. And we also do application code deployments with VCS repo, which if nobody's ever used VCS repo and you have your code and source control and you're ever thinking of deploying it for whatever reason with source control, it's really very featureful and it works very well, as long as you have your Git or subversion installed first. So this is the result of what we do after that. So now we have an instance, and it's running, and it has our users installed, and people can access it, and it has common applications. And if we've defined something other than the default node configuration for it, it comes up with whatever we've given it. And all of that happened in one command, which is amazing, given that not that long ago we were in a colo with servers on a rack that had to be imaged with a CD. So now we have, a whole bunch of developers and engineers and DevOps people all using Puppet, and they're all using Puppet to modify existing configurations, and they're using Puppet to create new configurations, and every once in a while somebody breaks something. The dashboard gives us an amazing way to actually see that happen, rather than staring at your aggregated Puppet log file that spins by God knows how fast and trying to anomaly detect out of that. You can actually watch the runs, watch the reports as they come back. When something goes red, you can go dig into it and see that it's broken and why it's broken and what revision broke it. This is very useful to us. So another issue for us was avoiding the Stampede. And this is particularly interesting on Amazon because with Amazon, you're sort of limited to the number of cores you have it on an individual machine unless you're running their giant cluster compute instances. So we're not running on an 8-core Optron machine. We're running on like a 4-core Amazon machine. And a Puppet master can destroy that if enough agents hit it. So we switched from Puppet's default polling mechanism to Puppet Commander. So Puppet Commander is, you can see it there, the mcollective plugins. It uses mcollective to sort of enumerate the number of simultaneous Puppet runs that are running right now, and then it manages how many should currently be running when, say you want 4 concurrently running, it watches and one finishes, it'll add another to that stack to make sure that you're sort of outpacing the number of cores you have on your machine. And it works really well. The other sort of great feature of this is that you can turn it off. So it's kind of difficult to tell all your agents that are out there polling to stop doing that in case of like some emergency where you broke a manifest somewhere in production. But with Puppet Commander, you actually turn off the commander and they'll stop running. So that's where we are now. We've gone from our 15 people 2 years ago to, I think we're going on 70, and we're experiencing that awesome exponential growth. And we're, with AWS and Puppet, keeping everything under control and fairly low overhead operations team. So we have some things we want to do next. We're actually still using a set of nodes files. We'd like to set up an external node classifier. It seems like there's a lot of options for doing this, but none of them has struck me as being really awesome for our use case yet. We might write our own. We've been tinkering around with LXC too, which I know a lot of people use Vagrant, and I've played with Vagrant as well, and I think it's really cool. But I've never really been satisfied with the application of VirtualBox as a container. And I think LXC as a lightweight container is really awesome. So I'd like to see us use LXC for sort of running a local instance of Puppet with a master to do development for. So another next step, we do use Amazon's scaling pools to a certain degree. So in order to do that, you have to like bundle your own AMI, then put the AMI into the pool, and it launches a certain number of them as the load scales. Having like an automated process to do the build bundle and then scale it will be convenient next step. Another one is Zookeeper. So one thing we do with Puppet is we have a factor library that sucks in all of our EC2 metadata, which lets us see convenient things in Puppet, like what security groups the instance is a member of, or how many ephemeral volumes it has, what the configuration of those volumes are. There's a massive number of facts get added in to that. But we've started using Zookeeper for sort of distributed application configuration across our application nodes. And it's gotten to the point now where it'd be really convenient to know the things that Zookeeper knows in Puppet as well. So I think a next step is going to have a factor library that sucks in Zookeeper information. So in conclusion, we went from the scariness that you saw earlier to fairly scalable and functional operations stack, and it works, and nobody's screaming, and all of our developers like it, and we're pretty happy with it, so we think it is win. So this would be the inquisitive questions time, if I can see anybody. No, I actually, one of my coworkers sat through the NOAA presentation. I didn't get to see it because I was working, but I did kind of leaf through the presentation, and it looks really cool. And I think that's probably something we'll be investigating. Anybody else have any questions? I'm always curious how many people are using Puppet configuration management on Amazon. I think I've run into a few of them.
You said you have 3 environments. Can you talk a little bit about how you manage the actual code for those environments without ending up with lots of duplication or long-lived branches, or how you sort of manage the actual code?
So we manage the Puppet manifest branches just like we manage like our code deployments. So we have a Puppet, as Puppet defines environments, and then we have a bunch of servers that run off of that environment, and those servers run off of the branch that's development, and that development branch, has configurations in it that are specific to development code. So it could actually be running, some developer's development branch of a particular application right then too. We use Git for pretty much everything, and we use submodules inside of our repository, so we could actually be running a different module version of somebody's forked mcollective module under our own Git repository for development than production. And Git submodules are god-awful scary when you start with them, but they do work fairly well once you figure out the like 3 things you can't do, otherwise it'll break them horribly. That was probably non-specific, but anybody have anything else? I don't know how I'm doing on time, but. Okay, well, with the lack of any other questions, I guess I'll conclude. Thank you.
Until 5 o'clock, when in here we are going to have Simon Jakesh, hopefully I've said that correctly, from Xenos, talking about Puppet and Xenos integration. And in the other room, in the cloud track, we've got Anders Wahlgren from Electric Cloud. And they should both be kicking off at 5 o'clock.